Hello, everybody. Are you there? Everybody, hello. Hello, Anthony. How are
Good
you?
morning.
Did you get your coffee?
I got my times mixed up a little bit. I
Where
thought
where
it
are
was,
you? Where are you, Anthony?
I'm in Melbourne, Australia.
Hmm. Well, it's for you purposely that I started this thing late. I started this thing at 2 p.m. I was starting it at noon, and then all you guys in Oz were going, "Oh, it's so early!" So I made it 2. So I
What
kind of
happened
split
to
the
go to
difference between
sleep?
Oz and Europe. I tried to anyway. So Daphne Kessel, that's not your real name, obviously.
No, I'm on my wife's computer.
Hello, nice to meet you. Who are you?
I'm Aaron. I'm new to this whole thing. I mean, I've loved arcade games and all that stuff since I was a kid, and I've amassed quite the collection, but realized that I don't know all the ins and outs and would love to learn more.
Okay, super. I'm sorry I missed your name. Say it again, please.
Aaron, Aaron.
Oh, Aaron. Oh, hey, nice to meet you, Aaron. Nice to meet you. And Sean, I'm not sure. Have we met Sean? I don't think we have. Have we? Oh, we have. Sorry. Yes, we have, certainly. So who else? George. Hey, hi, George. Mike, do I know you? I'm not sure I do. Are you
No,
there?
I've never been on one before, Randy.
Yeah. And where are you?
I'm just north of Milwaukee.
Ah, cool. Cool. Is it really cold there right now? Like snowy and cold?
Well, it's cold. We got a lot of snow on the ground, and we're supposed to get about another 8 inches tonight.
Yeah, I've been watching that. And hello, Paul. How are you?
Hey, Randy.
So Paul, I'm just gonna make you administrator, make host, just
Okay.
if that's okay with you. So I will call upon you to look at the waiting room and admit everybody. I still have not figured out how to make that automatically happen. I thought I had, but apparently I had not.
No problem.
All right, thanks very much. Well, I guess I think we have a couple of minutes here. Do we? No, we only have 1 minute. Hi, James. I'm so sorry. Forgive me. How are you? Nice to see you.
I'm well, thanks. How are you?
Yeah, great. Thanks very much. How are things in the Great White North?
White for sure.
Yeah, for sure. Yeah.
Yeah, we've been getting a lot of snow as well.
Yeah. Oh, whose dog is that?
That's mine.
Hey, what kind of dog is that?
She's Great Pyrenees.
Oh, those are nice, big,
Yeah,
giant poops this big.
yeah. There's a lot to clean up in the spring.
Yeah, there is. Oh, you mean you leave it go all winter because it just freezes anyway, and it's not a problem?
If they poop in the snow, you're not finding it anyway. So.
Oh, right. It'll melt down and sink. So, hey,
Exactly.
Austin Smith, hello, welcome. You're somebody new, and Raymond. Oh, is that
Hey,
Raymond
Randy.
Jett? It is. Oh, you're so
Yeah.
white. You know, it's funny. You're all white now compared to your profile picture. That's funny. How old is that photograph, Ray?
That photograph was, they took a picture that was probably about 12, 13 years old of me. And then they photoshopped it with the explosion and gave it to me last fall.
Oh, that's nice. Well, that's whoever.
Coworkers created it for me.
That's nice. And hello, Austin. I see that you're muted. Oh, there you are. Hello.
Hey, how's it going?
Fine. Thanks very much. You have a sufficiently geeky background that I like very much.
No, thank you.
Yeah. So, okay, can you tell us a little bit about yourself? Because we all kind of know each other mostly. Where are you from, and what's your deal?
Yeah, for sure. So I'm out of the Dallas, Texas area. I'm fairly new to arcade collecting and repair pinballs and what have you. I only started in that process a few years ago, but I have an aptitude. My background is computer engineering related, so I'd certainly welcome the opportunity to learn from an expert and someone who's been doing it for a long time to dive in a little bit deeper.
Oh yeah, well we have quite a few experts, especially I'm so pleased that Raymond Jett is here because Ray, would you say, or is it okay if I call you Ray, or do you prefer Raymond?
I prefer Raymond, but I'll answer.
Okay,
it
no,
anyway.
that's no problem. So Raymond, you're mostly digital. You're obviously an expert at that. I could see that. Is that your area of expertise?
Yes, sir.
And then Paul is a super monitor guy, kind of like I am as well. But he has a lot more experience with the latest really old crapola, no offense, that you guys are working on. When I was working around and I was the monitor repair dude, these were all common normal failures. But when you start seeing like polypropylene capacitors and polystyrene capacitors fail, or ceramic capacitors fail in weird ways that you would just never imagine, Paul has more experience with that, and he has a bit more experience with the damage that people do to their own monitors when they try to mess with them and they
Yes,
don't know what
unfortunately.
what they're doing. Boy, soldering is the number one skill. It just is, and I just don't know why people don't practice on junk. I mean, surely you have junk. Take all the parts off, put them all back on. Do it 10 times. I mean, it's not that hard of a skill. In my class, I have a fair amount of soldering practice that I do for the people that, they just have never soldered before. They barely know which end of a screwdriver to hold. And within like 20, 30 minutes, they got the hang of it. Really, it's not that difficult of a skill. I mean, no offense, Paul, you're good at it, of course, but it's just not. Anyway. Oh, hey, John. Hi. How are you, man?
Excellent. How are you?
Fine. Thanks very much. Thanks very much. And John is also likewise pretty much an expert, especially in monitors. Wouldn't you say, John, that monitors are an area of interest for you?
Oh, monitors are definitely an area of interest. I wouldn't call myself an expert though, but
Well, it seems like in discussing that you are. So anyway, Raymond, I hope you're not bored crapless today, but everybody, jump in if you have anything to say. This is totally. Oh, and hello, George. I'm so sorry. He's the administrator of the whole thing, and this was all his idea. So George, hello, and nice to see you guys.
Can you hear me?
Yes, I hear you, George.
Okay.
Yeah, I think we all do. Yeah.
Hey, Mr. Jorge.
Okay.
So Ray.
Everyone want to say hello? Say hello.
Randy, I do have some experience fixing monitors because I cut my teeth on TVs and monitors and things like that when I was growing up. And I still repair my own monitors. I just don't repair them for others.
Ah, okay. Yeah, that makes sense. I mean, although digital is a completely different realm, and you could be an excellent digital tech and not know anything about analog electronics, sort of. They're really two completely different disciplines, and I love them both. Just to digress for just a short time, in 1976, I worked in London, England, and I set up the logic department for a game distributor there in London, England, and they had no idea about anything. They could fix jukebox amplifiers, but that was the extent of their solid state experience. And this was just at the time that Midway released its microprocessor system, starting with Gunfight and Seawolf and, those guys with the daughter board and all that kind of stuff. So it was a really interesting experience to go over there and set that up. And I'm not exactly sure why I started telling you this, but just because digital electronics was really my first introduction to it, and I had been fixing black and white monitors like crazy before that. I really like them. I like them both a lot. You are seeing now, I think, Raymond, a lot more weird failures that I didn't see, like a lot of RAM failures, lots of memory devices. Is that not true, Raymond?
Oh, absolutely. And then you have the failing gates on the Fujitsu chips where they just fail and it's like they disconnect from the die. So you have floating gates and it causes all kinds of weird problems. But the neat thing is you can find a lot of those with what I like to call well-calibrated finger. You run your finger along the chip legs and all of a sudden you see the monitor go berserk. You found a circuit that's open.
Oh, that isn't what I thought you were going to say. Oh, that's really an interesting. You look at the monitor that is the actual game display, and when you touch the chip and you're essentially being a pull-up resistor or a pull-down resistor with your finger,
Yeah, you're adding some additional capacitance into the circuit, some noise. And when you hit the one, it only works when you're dealing with something that is part of the video display, of course. But when you have a 74LS157 that they're bringing 2 bits of data in, the sprites and the background together to put on the screen, then when you hit that open gate, it's going to show on the screen.
Oh, that's very interesting. I've always had a lot of good luck with what's known as the video probe. Do you know what I mean by that? Just a piece of wire, a probe with a 1K resistor in series with one of the video inputs of the monitor. And as you touch every node, something shows up on the screen pretty much, and it makes a signature that you're used to and stuff. Do you know what I'm talking about? Video probe.
Yes, sir. I've never used one though.
Oh, that's really useful. And some people do the audio probe as well. You just hook it up to an amplifier, and as you touch things, you're listening for sounds, sort of like Contact. If you remember that movie with Jodie Foster, where the blind guy was listening to the anyway. So I did get. If you guys have looked at that CRT workshop thing that George set up. I did get an interesting question about ground, which I thought was interesting. If you read that, the question was, gee whiz, why do we have interference? Sometimes the chassis is not grounded and the video is grounded and you get weird interference, blah, 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 blah. There was another interesting question about rejuvenation. Is the person that asked those questions here? No? Oh. Then I'm wide open for anything else.
The ground, Randy.
Was that you, Mike?
Yeah.
Oh, okay. So I do have an interesting discussion about what ground is and why that is weird. And, there's a short answer and there's a long answer. I always prefer the long answer, because that's the point of this whole thing really is a little bit of education. Does anybody else have a suggestion about something you'd like me to cover now? Let me just leave it open. Mike, just give me a second here.
I have something.
Yeah, George, what's your...
So I compiled a list of questions that people asked in the group, and at the very top of the list is interference. I put isolation transformer / interference.
Oh, okay, that's a real good one, and those both tie in.
Yeah, and then someone asked something about Sencor rejuvenators, so I put rejuvenators on the list, and we also have Purity, an upright monitor versus a cocktail monitor.
Oh, sure.
Purity.
That's a very interesting phenomenon.
Yeah,
that's for sure.
Yeah, there's...
Okay, so all of those things. All right, so if everybody's cool, and Raymond, again, if you want to bail and this is boring, I'm not offended. If any of you want to bail, I'm not offended. Wait, we have a new person coming in that none of us have heard of, right? Jimmy Gallo. Hello, Jimmy. Are you there? Yeah, that's all right. I'll just start. So let me just change the camera here and stand by. Stand by. And this guy.
Could I provide like a lead in to this isolation transformer interference thing?
Please do.
So I have a killer instinct here. It's like right behind me, and the man that like trained me on how to fix games, he had like a workaround for this back then, and that was to like just disconnect the earth ground to the monitor. And the monitor that I have in there is a Hanorex Polo, so that's a switching mode monitor.
Sure is.
Which, for whatever reason, if you interface one of those with like an isolation transformer, chances are you're going to get like what I describe as a ghosting effect. That's the interference, right? And then
I'm not sure what you mean by that. Could you describe that just a little bit better?
A ghosting effect?
Yeah, what do you mean by that?
You'll see stuff that's just in the picture. Like
you will see the same image repeated.
No, not so much that. It's more like kind of like a static.
Oh, more like a herringbone.
Static.
Yeah, is it herringbone? Is it herringbone?
Herringbone.
Herringbone. Diagonal lines that sort of drift around the screen.
Yeah. Okay. There you go. I haven't seen. Yeah. And there was a thing. If you looked at the video games that Williams was putting out from about like Narc on through, I want to say the last one with an isolation transformer was Mortal Kombat 3. They took a wire. This is another thing that the man that trained me showed me one day. you bridge the earth ground to the logic ground on the screw terminal power supply, and that eliminates it. And then you could have earth ground attached to the monitor again.
Whoa.
Yeah.
Let me repeat that back to you and see if I got this right. You connect the common, the DC ground, to
Right.
the frame ground.
Right.
Whoa.
And that gets rid of all the interference in the screen.
Okay.
It was something that Williams did. So if I ever came across it on a game and it had like a screw terminal power supply in it, that's what I would do and clear it all up
Consistently?
Yeah. Yeah.
Well, it really, that ties in with what I was going to say. So I just had never heard anybody else say that.
Yeah, George actually helped me fix a double dragon that I had issues with, the exact same herringbone pattern. And as soon as you touch those two screw terminals together on the switcher, it's gone.
Okay. All righty then. All right. So let me, if we're ready to go here, let me switch cameras here and stand by. I wish I wasn't quite so lame at doing this. Hang on a second. There we go. All right. All right, guys, give me one sec here. All right. So just, keep an eye if anybody wants to enter and just kind of let them in, please.
No problem.
All right. So, let me start with let me just start with the short answer just to get it out of the way, and that is that I have seen the exact phenomenon you're talking about, and my experience has been more or less the same. That you have weird interference on the screen. We could call it anything. We'll talk about what herringbone interference looks like in just a little bit. And sometimes you see, oh, the ground's not connected, and you connect a ground to the monitor chassis or something, and it goes away. And in other cases, the interference is there, and you go, oh, I see that that's grounded. Let me try removing the ground, and you do, and the noise goes away. Has this been anybody else? George, has this been your experience as well, just out of curiosity?
You mean like both ways? Yeah, definitely.
Yes.
Yeah.
Sometimes it does one way, and sometimes it does the other way.
Yeah, no,
Okay.
Right. Yeah, I know of people that like don't connect the earth ground at all to the monitor, and that's what I was doing for a few years until I figured out this method, and then I was like, oh, we can connect the ground now. Just for
Okay, so
pure.
well,
yeah,
go ahead.
for like pure safety purposes, you do want the earth ground connected to the monitor, do you not?
I personally don't think it's a matter of safety at all. I really don't. The monitor's not going to build up any sort of static charge, and there's no sort of AC, what you would call the mains in Australia or Europe, AC shock hazard or anything. You really don't have to have that. In general, the earth ground is important in a video game for several reasons, and I'll step back and talk about ground again in just a little bit, but several reasons. Number one is for static electricity issues, in that if the game is not grounded and you zap it with 10 or 20 kilovolts of static electricity, where's that going to go? I mean, normally in a video game, everything that's metal on the outside, coin door, carriage bolts on the control panel, everything should be connected to an earth ground. That's actually a kind of a requirement, kind of a legal requirement. And if it's not grounded, where does that static electricity go? It goes into the board and can blow chips and stuff like that. So, one of the things about having the game grounded is just for static electricity. Another one, though, is to remove electrical noise. That is to say, as part of the power supply itself, which is where perhaps this herringbone interference is coming from. And and other things, they generate a lot of what's known as EMI, electromagnetic interference, EMI. EMI is a big giant issue, and when you think about how a circuit works in general, you're not really kind of thinking about EMI as a, you know, kind of a beginning technician. But EMI generation is a huge, gigantic problem, and we have to get rid of this electromagnetic interference. For example, when transistors are switching on and off, every time they switch on and off, they generate some EMI, which is like an undesirable kind of thing. So, in for example, the filter system for the AC power, just as an example, when the AC power comes into the filter system, we're going now into a power supply. It starts out, of course, with a fuse, but then it goes through the line filter, L-I-N-E filter, as you probably know. And the line filter consists of several things. It consists of like a coil of wire, which is like this, kind of like this, and it consists of some capacitors, and typically these are like 0.1 microfarad. They are not electrolytic capacitors. They're like polystyrene or polypropylene. Hey, Raymond, you're the expert. Do you know, are they polypropylene? They're polypropylene, aren't they? Do you know?
They're stacked metal film capacitors.
Oh, stacked metal film. Well, thank you very much. I'm glad you're here. And please feel free to chime in if you know anything. And then, you know, typically on the other side, there's a couple of capacitors. Again, these are small, like 0.1 microfarad kind of thingies. And this guy is connected to the earth ground. So the point of the line filter in a switch mode power supply is to prevent electrical interference from getting out of the power supply, which is here, and into the rest of the things like your monitor, for example. So if this earth ground is not here, there's really no place for that EMI to go. As the transistors, the MOSFET or bipolar junction transistors in the power supply are switching on and off, they're generating a crap ton of EMI. A switching power supply generates a ton of EMI just as a natural byproduct of its natural function. So the purpose of this earth ground is to suck the EMI off through these capacitors. The capacitors will pass this high frequency EMI, which is generated by the power supply, to ground to get rid of it, but not really affect the 60 hertz that's coming in. Remember that the AC power coming in is only 60 hertz, and that's super low frequency. So these small capacitors don't affect that, but they affect the high frequencies. So one of the reasons where you might have that herringbone, where if it's, you know, you have it, you go, oh, the ground's not attached, and you put a ground on there and it goes away. But I can't explain this. I can only give you my practical experience, because remember, I'm just a tech. I'm not an engineer or anything. I'm just a game tech. That's all. Sometimes you see that there is a ground, and there's ground on there. You take it off and it goes away. And sometimes you put it on there and it works. And of course, I'm also assuming that your AC power plug has the proper third pin, the ground pin, and, you know, all that kind of stuff on it. So,
hey, Randy, you're also assuming that the switching power supply you're putting in that came from China has those capacitors in it.
Well, that is an excellent point. And if I could just step aside for 1 second and talk about that, because you're absolutely correct. At one point, I lost the power supply for my laptop, my laptop computer there. I had lost the power supply for the laptop. And being the cheapskate that I am, I went online and got the very cheapest power supply I could possibly get, because I'm a cheapskate. And this power supply was so terrible, it threw off so much EMI that not only was there interference on the monitor of the laptop, but when I tried to synchronize the laptop with a projector that I use for classes, it wouldn't synchronize. If I disconnected the power supply and ran off a battery, synchronized perfectly, and so on. So yes, that is absolutely true. Absolutely true. So anyway, so I can't explain why it is that sometimes putting the ground on works and sometimes taking it off works, but it does. Joining the DC ground and the earth ground, I guess could be, I think it could be kind of dangerous. It depends on what you're doing. So I want to talk for just a minute about isolation, if that's okay now, and why you need this isolation transformer and why some monitors need it and some monitors don't, if that's okay with you guys. Are you guys okay with that? Everybody
Sounds
cool
good.
on that? Okay. All right. Because I think it's an interesting story, and I have written an article about it. It's in that big blue book that I publish, and I could just post it really for you. But here's the deal. So let's talk about for just a second about isolation and the isolation transformer. Transformer. Sometimes abbreviated XFMR, as you know. Sometimes they use the letter X as an abbreviation for trans, like transistor is sometimes abbreviated XSTR, as you probably know. And as you also know, a transformer, isolation transformer, is a transformer with a 1-to-1 turns ratio. Whatever you stick in is what comes out. In United States of America and North America, it's 120 volts AC in. Down in Oz, of course, you're 220 or 240? What do you call it? 220, don't you? In Australia?
Technically 240.
Oh, 240, really? Okay.
Yeah.
I guess that makes sense, doesn't it? Anyway, so whatever comes in is the same thing that goes out. So the reason that you need the isolation transformer in monitors that use a linear, sorry, let me back up. As you know, there are two different kinds of power supplies you find in monitors. In the old monitors before probably 1990, they used what we refer to as a linear power supply. It's a bridge rectifier, a capacitor, a voltage regulator. I mean, it's really, there's nothing, there's three parts to the thing. And in the more modern stuff, I don't know when they started doing SMPS, probably 90 something or other. They have a switch mode power supply, which you can identify by the yellow transformer that's on the power supply. Is everybody here in the room clear on that? Anybody not clear on the difference between or the knowledge that there are two different kinds of power supplies? Everybody okay on that?
Yes, sir.
All righty then. All right. So transformers have this property that we refer to as isolation. And what they are specifically referring to in this case is that there's a coil of wire here on the left side. And as you know, it's known as the primary. It's called the primary winding of the transformer. And the output is on the right-hand side. And as you know, that is known as the secondary winding, really, of the transformer. And that's the output. The primary winding is the input, and the secondary winding is the output. And as you know, this is standard operating procedure for schematics. In general, in a properly drawn schematic diagram, inputs are on the left and outputs are on the right. Right. So, but these two coils are electrically isolated from one another. In other words, there's no direct galvanic connection, no metallic connection. It's known technically as a galvanic. I don't even know how to spell it. I don't know how to spell it. That's not it. Named after a guy named Galvani, who kind of messed around with what he referred to as animal electricity. Anyway, no metallic connection. In other words, if I put my meter on the ohm scale, continuity, and put 1 meter probe on this side and 1 meter probe on the other side, there's infinite resistance between the two. There's no connection at all between the two. There's only a magnetic connection. Because as you know, the way this thing works is that the primary winding, which is the input, is connected to the AC power. Through a fuse, of course. And that, of course, causes current to flow through it. And as the current flows through the winding, it builds up a magnetic field. But that magnetic field surrounds not only the primary winding here on the left, but also the secondary winding on the right-hand side, because they're both wound around the same magnetic core. And it's not really the point of this discussion to talk about how transformers are constructed, but they share a magnetic field. So as this magnetic field builds up, as the alternating current builds up in voltage higher and higher, the magnetic field gets bigger and bigger, and that magnetism is induced, it's called induction, into the secondary winding, and it causes electric current to flow out the secondary, is my point. So that's really the way a transformer works. As the AC causes the magnetic field to build up and collapse, and then build up and collapse, build up and collapse, it causes alternating current to flow in the secondary winding. So there is this thing, just to reiterate, there is this thingy which we call the isolation transformer, and it's simply a one-to-one transformer. We put in 120 volts AC and we get out 120 volts AC. Huh. Seems like a useless piece of junk, doesn't it? Right? We put in 120 volts, we get out 120 volts. It hasn't changed the voltage in any way. What's the point of that thing? Here's the point. And it comes down to the way our AC power distribution system works. As you know, in North America, and it's a little different in Oz, but in North America, the way we work it is our AC power receptacles look like this. There's a short slot, there's a long slot, and there's sort of a half round thing here. So the short slot over here is what we refer to as the hot side of the AC power. That's where the mains is, as you call it down there, the 120 volts AC, that's where it is. It's the only wire that has juice on it. Just that one wire. That's it. It's called the hot side. Here in America, the way our color code is, this is the black wire. This is the black wire that you hook up to the AC power plug. In Europe and elsewhere, all the rest of the places in the world, it's brown. Everywhere else. The other side over here is known as neutral, and it is 0 volts. It is what we refer to as the return path for the electric current. The electric current has to come out of one place and go into another place, and that's where it goes. So it's the return path. It is 0 volts. It's where here in America, we use the white wire for that. Elsewhere in the world, it's the blue wire. So it's easy to remember that, by the way, because you think of blue as a cool color like water, neutral, cool, blue. You know, like that. Anyway, and then this guy right here is the earth ground. This half round thing, and the way the receptacles work, and I'm not sure about Australia, but elsewhere in Europe, they've got a couple of pins like that, and there's an earth ground here and an earth ground here, and whatever. But so this is connected to the earth ground. A schematic diagram of earth ground is that three lines of diminishing width kind of forming an arrowhead pointing down to the bottom of the schematic, like as if it was pointing to ground. This is connected to the actual Earth itself. The actual Earth, the actual planet Earth is our return path. It's 0 volts. It's what we call Earth ground, or as you would call it in UK, and I think probably Oz as well, Earth, right? It's Earth, as opposed to chassis Earth or chassis ground. Right. So that guy is actually connected to either a cold water pipe that's buried in the ground, or a rod or a stake that's pounded into the ground. Somehow it's connecting to the earth itself. And this system actually was first developed for the telegraph. When Samuel Morse first made the telegraph system, by using earth as the return path, they can make the telegraph work with just one wire instead of two. So that your copper usage is cut in half that way. And so that's a pretty cool deal. All right. So But okay, so wake up. Everybody knows this, I think. Wake up, everybody, wake up. Here's the important part of what you need to know about this. And that is that at the circuit breaker panel, the fuse box, if you want to call it that, but the circuit breaker panel, this is important. Neutral and earth ground are connected together. They are one and the same electrical point. The neutral is the return path for the electronics inside the thing. The earth ground goes to the outside of the thing, and that's what you would call a safety ground, right? So someone had mentioned safety earlier. That's the thing that is the kind of safety ground, and so in that regard, yes. In that regard, yes, ground is a safety deal. So everybody with me, those two things are connected together. I'm about to erase this, and we're going to look now at the schematic diagram for the actual monitor. Everybody okay? So far, questions so far? Cool, all right. So put on your thinking caps, because here's the actual deal. And I'll be honest with you, it took me some research to do this, to figure out what the heck was going on here. I really had to not just think about it, but I had to actually call some people and go, you know, so anyway, so here's the deal. So in something like a K7000 monitor or G07 monitor or any of these older monitors with the linear power supply, the way that power supply works is this. There's the AC power that comes in, goes through a fuse, and it goes into a bridge rectifier. It might go to a small value resistor first, but typically it goes to the bridge rectifier. So the bridge rectifier, as you know, is made out of 4 diodes here. And it's the thing that turns the alternating current into direct current. The negative output of the bridge rectifier is connected to the chassis. This kind of a monitor is what we refer to as a hot chassis monitor. And it's very common. This was especially common in consumer TVs. Very common to have a hot chassis monitor. Most of them were. That's why they were in a total plastic shell. And it says, no, don't open this, no user serviceable parts inside, because they did not use an isolation transformer, and it's a hot chassis monitor. That is to say, one side of the AC power is connected right to the chassis, that's the chassis ground symbol, through a diode. So let's just say, for the sake of discussion, that this is the hot side, and this side right here is the neutral side. Okay. And let us also say, for the sake of discussion, that without an isolation transformer, you have decided it would be a brilliant idea to put an earth ground on your chassis of your monitor, the green wire with the little clip on it, because you think it should go there. Well, let's think what's going on here. Remember that neutral and earth ground are connected together at the breaker panel. If they're connected together, and if this side is neutral and this side is earth ground, have we not just shorted out that diode completely? Yes, we have. So what happens now is that as the AC power is, let's say this side's positive and this side's negative, and the current should be blocked from going in this direction. Now it's not, of course, and it goes right through to earth ground. One side of the of the AC power goes right to earth ground and just fries these 2 diodes. So not only does it fry the diodes, but it will vaporize this trace right off the board. You've probably seen it, John or Paul. Paul, you've probably seen it for sure.
Many times,
Yeah,
right?
where you pull the monitor out and you go, well, where's that copper trace that goes from there to there? It's gone, and you know exactly what happened. That somebody plugged it in without an isolation transformer and put the earth ground on it. If you never put the earth ground on it, it would work perfectly. And in my class that I do, which I've been doing for lots of years, I used to haul around a suitcase full of isolation transformers. I live in San Diego. I do a class in Chicago. One of my big giant suitcases would be full of isolation transformers because we had hands-on labs where we would fire up monitors and stuff like that. And I just finally got tired of that. And at the end, it was just a suicide cord, just an AC power cord with a couple of clip leads on it that we could power up the monitors, with the caveat, the warning that do not ground this chassis. In other words, don't touch the grounded tip of your soldering iron to the chassis, because you will vaporize that trace off the board and you blow these two diodes. And I can't explain this. Paul, maybe you have seen this. Have you seen the voltage regulator also be taken out by doing this? Because
I've seen a few taken out with the two diodes blown. The voltage regulator has been blown as well. Right. Yes, I have seen that.
Okay.
Hey, Randy.
Yes, sir.
I've also seen where it vaporizes the ground trace on a Mortal Kombat 4 board and on Seattle boards, because they don't have isolation transformers in the bottom of the cabinet, and they put a monitor in that requires it.
Well, yes, because if you don't give it a ground, it's going to find some place to go to ground if possible. And that could be through your DC grounds, through your board, through your wire harness. You can melt a wire harness. There's lots of super bad stuff. Now, why don't you need it with a more modern monitor? Because almost all transformers have this property known as isolation. It doesn't have to be called an isolation transformer specifically. All transformers, except for a certain kind called an auto transformer, have this property known as isolation. So in a modern monitor, the AC power comes in, goes through a fuse. It does go to a bridge rectifier. There's no question about that. And if we grounded this part of the circuit, for example, for those of you that are more advanced, if you wanted to use an oscilloscope to probe the primary side of the power supply, you better be isolated. You have to have this thing plugged into an isolation transformer, because the primary side is connected to the earth ground. So you've got to be really careful about not doing that. You just can't do that. But once we've made our primary voltage of 160 or 170 volts DC, the next thing that happens is that it goes to the primary of the switch mode transformer. Remember, that's the small little yellow transformer there. It goes to the MOSFET, which you know is the switching transistor, and surprisingly not that common of a failure. And then there is the core, which is a ferrite core, and so should technically be drawn with a dashed line. And then here's the secondary side. So on the secondary side, is where they rectify it, and as many secondaries as you need. This part is isolated. So everything from here on there is totally isolated. Just because it's not called an isolation transformer doesn't mean it's not isolated. The primary side is not isolated, but the secondary side is isolated. Does that make sense to everybody? So that's the reason why you need the isolation transformer sometimes, and in other cases you don't.
If you're working on a monitor that has an isolation transformer within it, so you don't need an ISO transformer to plug it in. If you plug it into an ISO transformer, then you can probe the power section. The
primary side, you absolutely, you mean probe, but you using an oscilloscope? Sure.
But you could be plugged into an isolation, transformer.
Because the oscilloscope, you definitely don't want that isolated, and that is hooked up to the earth ground for noise and noise abatement and so on. So yes, you absolutely can. And here again, I found out the hard way, because when I first encountered switch mode power supplies, and I kind of went to myself, wow, what is this thing? I never seen this before. Let me hook up my oscilloscope and look at it. And I vaporized the ground trace right off my oscilloscope. I mean, the thing with the wire with the clip lead on it, it just disappeared. I mean, it exploded on my workbench. It scared the living crap out of me. And I did it twice. I did it twice because I'm an idiot. So there you go. So if you have ever done that, you're in good company. I think you're in good company. So there's the other can I continue talking a little bit about ground and why and what's the difference between the power ground and the video ground interference wise?
I just like to make a comment about isolation transformers.
Yeah.
If there's newbies out there who have Nintendo cabinets, do not plug your power supply or your plug into the wall. For some reason, people who are brand new see that plug and they're like, oh, I could plug this into the wall and get power directly from the wall. You know what I'm talking about, Randy?
Are you talking about the 100-volt output of the transformer versus the 120 of the AC power? I know I don't know what you're talking about.
You got a plug that looks like a plug that you plug right into the wall in Nintendo cabinets.
Yeah.
And you wouldn't believe how many chassis I got just because they plugged them into the wall, blew them up for some minor problem they could have probably fixed even without pulling the chassis out.
It was always a bugaboo for me because until I ended up with a 100-volt transformer that I could use, people would give me these monitors to fix. And I didn't really have this is a long time ago. I didn't really have a good way to fire it up. And I was afraid to plug it into the 120. It's 20% higher than it should be. And that's a lot, really. Okay.
You know, I solved that recently. I've had 100-volt transformers. I just got a Variac transformer from Amazon. It was like $50, and I could put any voltage I want on it, just like that.
Yeah. Did you run the output of the Variac into the input of an isolation transformer?
Yep.
And then
okay,
that's good. You could actually do it either way. You could isolate first and then Variac it, or you could go the other way. It wouldn't make technically any difference. All right. So there are a couple of different kinds of ground, and as long as we're talking about it, you know, Raymond, I sure hope we're not boring you too much there, brother, because I know you know all this jazz.
Not at all.
All right, great. So as you know, there are two different types of ground, and I kind of just mentioned it, and one is the earth ground. And that's this symbol right here. And sometimes it's abbreviated kind of like a triangle like that. And then the other thing is the chassis ground. And the chassis ground, and the symbol is like this, is where that there is a common 0-volt point, ground is 0 volts, between the components. It just doesn't happen to be hooked up to the earth itself, such as in an aircraft or an automobile, where an automobile is up on 4 rubber tires, which are insulators. It's not hooked up to the earth. It's what we call a chassis ground. And ostensibly, you would think that ground would be ground. That is to say, if I have two things that are hooked up to ground, one thing, doesn't matter what it is, over here, and another thing over here, that these 2 points are precisely exactly the same. And theoretically, you'd be right. Theoretically, those two are precisely the same point, but in fact, they're not really. And here's the point, that in a power distribution system, let's say, let me think how I'm going to do this here. Power supply. Printed circuit board. I'm not quite sure where I'm going with this thing. So coming out of this thing, we have the plus 5 volts DC, V sub CC, as you know, it's often called, that goes to the board itself. And then we have some kind of a ground, which is the DC ground, which is the return path. So if we were looking at this in terms of what we call conventional current, the current flows out of the power supply into the board, goes into all the integrated circuits and all the other jazz that it has to do, and then it comes back out this and returns right there. Well, there's resistance here. a theoretical ground, there's no resistance between the grounds, but in fact, there really is. And so there is current flowing along this ground wire, and the current causes interference. If it depends on how noisy the power supply is, though. But every little tiny bit of noise that goes this way that causes the voltage to jump up and down is gonna be reflected back again, and that same amount of current, since the current is the same everywhere in the circuit, is reflected on the ground as well. Well, your monitor, of course, has this ground connection. So on the monitor, this is the let's say the 6-pin connector here, right? So pin 1 is red, pin 2 is green, pin 3 is blue. Pin 4 is the ground. It's the video ground, though. And it's not this ground. It's the ground that connects to pin P of the JAMA connector, doesn't it? Which is right in the center of it. It's a 26-pin connector, whatever it is. Pin P is kind of right in the center, and that's not a coincidence that it happens to be there. They don't want any noise on that ground. So I could connect the ground right to the power supply ground. The video ground here could be connected to there. And if I turn the monitor off or turn the game off and did a continuity check, it is electrically the same point. But this has a bunch of current flowing through it, and this does not. The video signal is almost no current whatsoever, and the power circuit is a crap ton of current. So even though these are technically both the same ground, you don't want to mix them up because you end up with this weird noise problem. And we talked about that earlier. Now, connecting the frame ground, the thing that's labeled FG, which some people mistakenly refer to as field ground, is actually frame ground, meaning the metal frame of the power supply. That's the thing that should be connected to the 3rd pin of the AC power distribution. That's frame ground. I really don't, I cannot explain why they would put those two together and why that would take the noise away. I have seen that before, and I've done it before, where I had noise, there was a jumper on there, I took the jumper away, the noise went away. I had noise, the jumper was not on there, I put the jumper on there, the noise went away. I cannot explain it, I am just a technician. I can only tell you empirically this is what I observed, and I've observed it a ton of times, and I never bothered to investigate why that is. So does that make sense? I'm gonna go say.
Hey, for what it's worth, I've had that issue a couple of times with some cabinets, and it can sometimes be board dependent as well as power supply dependent and wiring dependent. I changed all the variables and I was having the same issue. So same deal.
I agree with you. I agree with you 100%. Oops. Sorry. I agree with you 100%. All right. So, I mean, was that satisfactory? Everybody okay? Anybody else have another question about monitors?
Sure, I got a question, Randy.
Yes, sir.
I had a few K7000s come in the past couple months. The width coils on them, they were 19-inch. They were only the 19-inch version. And the width coils were completely melted and burned a hole through the boards.
Yeah.
Now,
I addressed that on the board. I mentioned what it was. Do you want me to cover it again?
I must have missed that. Was it from cold solder joints, or was it from?
Yes. Yeah, precisely so. The solder joint, there's a lot of current that goes through the width coil. Bad solder joints on the width coil, because it does kind of have a lot of current and gets warm, it starts to arc. As soon as it starts to arc, I guess it's the CO2 in the atmosphere or something, it carbonizes. Then now we have a conductive path, and it's a resistor, and then it just burns out. So you and I have both repaired that a bunch of times. The way I have fixed the board a bunch of times by flooding it with epoxy, pulling the parts out, damming the board on the bottom with a piece of duct tape, and just flooding it with epoxy, a thin layer, let it harden, and then I drill new holes for the parts. What do you do?
I pretty much do the similar if I can find a width coil. Usually the width coils are completely destroyed and melted into pretty much just a goo.
You can't find them as a replacement part?
There's no replacement width coils. My solution was taking them off of 4900s. 4900s are pretty much the same width coil, except they don't have that I guess that black ferrite core over them.
It's called the slug.
Yeah.
Oh, on the outside, you mean? Oh,
Yeah, on the outside.
Oh, that's important. That increases the inductance measurement.
Okay, I didn't know that.
Oh yeah.
Because the 4900 seemed to work fine with the 7000s, but I didn't know if that was actually needed or not. Because they usually just fall off when they're melted anyway, so they're pretty easy to.
When I think of all the CRT monitors at the sides of the curbs that I drove past that I should have probably picked up and just stripped the parts off of, but I've stopped being a pack rat. I'm not, I don't even have hardware anymore. It was just too much. I had tons of the stuff, and I just finally thought, I'm not that much of a hobbyist anymore, and I'm not doing it for a living, so get rid of it. There you go. Oh, hello, Joe Spinelli.
Is there any way to test a voltage on the heaters? Because I got an RMS fluke, but I still can't test the heater voltage.
Well, what does it show you when you put your meter on AC and you try to measure?
It shows like 2 volts.
Okay, so that's a reasonable thing to discuss. Here's what Paul is talking about. The heater of a CRT is designed to work off 6.3 volts RMS AC. It could run off a DC as well, but 6.3 volts DC or AC doesn't matter. It's just a heater. That's all it is. In our world, our real world, by and large, it is actually driven off of a winding on the flyback transformer, as you know. It's really just a few turns of wire around the flyback transformer. The flyback transformer creates not only just the high voltage, as you know, but low voltage power supplies as well. For example, in the K7000, there's a 24 volt supply that's derived from the flyback. There's a 12 volt supply that's derived from the flyback, and this 6.3 volt equivalent, which comes off the flyback. But the flyback transformer is operating at 15 kilohertz, 15,750 hertz. And your meter, even if it's a fluke, a good meter, is calibrated for 60 hertz. So when it has a high frequency AC signal, it's very, very confused. And what that signal really looks like is this. Let me just switch cameras here. Stand by.
Yeah, any diodes you have in there aren't going to be able to handle that frequency. That's where you need the Schottky diodes like you have in the horizontal output section, the flyback section.
But we wouldn't rectify that. There'd be no reason to rectify that. So pay no attention to the man behind the curtain there. That has nothing to do with nothing in this particular case. Hang on, just give me 1 second.
I think you got to switch to your other camera, Randy.
Don't you see it? I see it. What?
It's the far view, though. I don't know if you're on your other camera that's up to
No. It's the only other one I got. I could zoom in. What the hell? Do you see me now? Do you see my face?
Yep.
Okay.
But we can't see the board. The board's too far away.
Oh.
Yeah, you're not zoomed in on the board.
I think you're on the laptop camera, not the ice.
Oh, you're right. You're right. Sorry. Thank you. Sorry for being lame. God. Sorry. Stand by. Where are you? Stand by. We'll edit this part out. Come on. What's going on here? There we go. Yay!
There we go.
Thank you for keeping me honest. So this is the flyback transformer, and there's a lot of outputs. Of course, there's the second anode, which is the super high voltage thingy, but also coming out of this thing is just a few turns of wire that goes to the heater. That's the heater schematic of the CRT. So this is made to work off of 6.3 volts AC RMS, root mean square average sort of a thing. But what's really coming out of this thing is a pulse that looks like that. It's a pulse that looks like this, and the pulse is like maybe even 20 volts high in amplitude. It's a big giant pulse, but it's very narrow. So that when this is all averaged out over time, when this voltage is averaged out over this time period right here, it averages out to be 6.3 volts AC. Well, your fluke meter, all of our meters really, are calibrated to show you what's known as true RMS at 60 hertz sine wave.
Okay.
60 hertz sine wave. That's it. No other waveform, no other frequency. That's it. Because that's what it's expecting you to measure, of course, what's coming out of the mains. So the AC power. So when you give it this, it's very, very confused. But all you have to do really is just use your fluke and measure every monitor you get to, measure the heater voltage at pins 9 and 10 on the top of the very top of the CRT socket. What does your meter show you? Now you know that that's normal. So what is 6.3 volts AC RMS at 15 kilohertz shows up on the fluke as 2 volts AC. And you call that good.
I'm no engineer or anything by any measure, but why wouldn't they just use the 12 volt line on the flyback and put some resistors in there to make it 6.3 volts?
Oh, it's a lot of current. The heater itself draws a lot of current. It's one of the highest current drawing things in the in the CRT. I couldn't tell you how much. I want to think it's an amp or two, at least. I think it's got to be at least 12 watts, wouldn't you? Raymond, are you around? Do you think that that's reasonable? 12 watts, 15 watts? No, Raymond's gone. Oh, well. Anyway.
No, I couldn't figure out how to work the mute. Very reasonable.
Oh, okay. So anyway, so that's why. But you know, my suggestion, and this is how I taught myself a lot of this: spend a bunch of time probing around and measuring stuff on a good working monitor. And of course, if you have A/B comparison, if you have a good working one and you're working on a bad one, you know, you always can do that. I am often, still to this day, very surprised where I will surmise that something should be a certain way, but when I'm really measuring on a working thing, it ain't what I thought it was going to be, and it's some other thing, you know, and that's how you learn. That's how you teach yourself, because nobody's going to teach you, probably. Anyway. So any other questions about life, the universe, and everything?
Yeah, I have a quick. Oh, go ahead, sorry.
I had a question there, Randy. So you figure the ground coming off the. I've seen transformers that had a ground coming from the iron core of the transformer.
Yes, I suppose I've seen that. Yeah. I don't get your question.
Well, is that for noise as well? It sounds like it would be.
You know, that's a good question. I'm not sure why you would want to ground the core. I suppose if there were ever a short from a winding to the core, you would not want the core to be hot to the touch, hot electrically, I mean. And so if it was grounded, of course, it would blow the fuse the instant the winding touched the core. That'd be a total wild ass guess, though. That's, you know, I are just a technician, so I don't know. Hello, Joe Spinelli. Have we ever met, Joe Spinelli?
I've seen you on the post, but no, thank you for doing this. And I've been following along at home, learning as I go here. And actually, I had a quick question for you. In particular, because I'm now moving out of the K7000s and G07s into the D9400s by accident, because I offer to help somebody.
Oh God, good luck. Okay.
Well, that's what's on the board right now, and on the bench, and it's a tricky one. So
they all are.
The question I have for you is, so I've done the cap kit, I'm working through transistors, that stuff I can kind of do. This one has this Thompson tube that's notoriously bad for having this stuff flake onto the yoke and frying it. And the question I have is, I took the yoke off it looks good, but there's this insulation coating that they use on it. And I just wanted to know what the purpose of that serves. Is that something that you should try to repair? Or, well, why were they doing that in the first place? But
this is a Thompson tube. Is it made in France?
No, it's made in Mexico.
Oh,
yeah.
And this thing that you're calling insulation, what color is it?
It's black and it's crusty. So
That's
if you
not,
pull,
yeah, that's not insulation. What you're looking at there, if I believe, is what I think you are, is the aquadag on the outside of the monitor. And that is conductive. It's a conductive paint. It's graphite, and its point is to be conductive. So that would kind of explain why that flaking off could be an issue. But I personally am not familiar with the issue. Is anybody else?
I've seen those yolks just literally fall apart on those digital monitors. You know, they're very poorly made. I don't have too much experience with those though.
Yeah, I don't have an answer for you, Joe, other than to tell you that that's not insulation. It's the same stuff that's on the outside of the picture tube that the CRT ground is touching. Correct?
No, it's different. It's different than the aquadag. Yeah.
It is.
Let's take a close-up video if you can, so we
Can you see? Yeah. Let's see what it
See
looks
if you
like.
guys can see if you guys can see that there. See how it's a different. This is the aquadag, and then this is sorry, I'm doing this. Oh, you know what? I'm doing this the wrong way. Hang on. So this is the aquadag, right? And then there's a different color of a coating here that's like a darker black. And
raise the camera up a little bit. There you go. Whoa.
Sure thing. Oh, sorry, other way.
I don't know that that's not aquadag. I think it has to be.
Yeah, and then inside you can see how it's peeling and flaking a little bit. But it's not, when I test it with my meter, it doesn't show as, it's not completing a circuit, not that I would expect it to, but that was my test as well. Does it conduct? And it doesn't.
Oh, I'm sorry. I have no answer. Sorry.
That's all right. Figured I'd ask, but thanks for doing this.
Yeah, no, Paul, John, have you, George, Ringo, anybody?
Haven't worked on one of those monitors yet, thank God.
They are extremely difficult to work on. I'm more familiar with the Tovis version of the same monitor. It's really it's either a licensed or rip-off of the Tovis design. Boy, it's really complex. James, have you worked on this digital monitor at all?
I only had one, and it fried on me pretty quickly and just got rid of it.
Well, I've done that. I'm kind of ashamed to admit it, but a couple of times I just gave up after a few hours. It was like, I don't know. Is the microprocessor bad? I don't know what's going on here. And to have to learn this whole system. And I mean, I think to really work it, you'd have to interface with the I2C bus that controls everything. And I wasn't prepared to do all of that. So.
Yeah, I'm in the same boat. I'm doing the things that I can work on my bench, giving it the college try and going for it. But when I pulled the yoke off, because I read a number of people saying the yokes have a habit of frying on these things because that coating basically flakes onto the yoke and cooks it. Yeah. And so this one doesn't have that problem, or at least that bad. But yeah, it's been an adventure. I mean, there's, 60 caps on this thing. That was a pain enough as it was.
Did you measure them and find them to be bad, or did you just shotgun the whole thing?
No, I actually found a number of them to be bad. I have an ESR meter.
Okay,
and
great.
I have an Atlas, and I was going one by one, and a number of them in the power supply were bad, which led me to believe maybe that's my problem.
Yeah, you would, yeah.
So that's when at that point I was like, well, I already got to do 15 of them. I might as well just, do them all. I got it on my board or on my bench.
Yeah, no, but it's very disheartening when you do that, isn't it? Joe?
Well, as I said, it was a guy that I'm helping out. He runs a vintage computer museum by me, and so I said, I'll give it a shot for you, and if I can get it running, great. If not, I'll send it out to somebody who really works on these things. But it was worth a shot.
That's exactly why I don't work on them, because you could dedicate 2 or 3 hours just doing a cap kit and it not work, and then what can you tell the customer? Oh, I tried, but I couldn't get it working.
And you can't charge them anything.
Yeah,
exactly.
Yeah, and I'm doing this one just to be nice. The moral of the story is when someone says they have an old arcade monitor, make sure it's an actual old arcade monitor before you take it in. K7000, I mean, I can do those in my sleep at this point, but yeah, this one, anyway.
All right. So anybody else have some other idea about something to talk about?
I have in my multicade, I have a 27-inch Macavision. And when that dies, I'm just taking it out and putting the K7000 in it. I'm not even going to mess with it because it's a digital tri-sync, and I just don't want to mess with something like that. It's it'll take too long, and you probably won't even get it working. So
that's a nice Canadian company, MacVision.
yes.
I had a hard enough time with doing a Neotech, a 24/25, because you couldn't figure out any real schematics on it, what the B plus actually should be, and yeah, the older ones just seem to be a lot more fun to work on. I'll tell you.
And plenty of information.
Exactly.
And more rewarding to be successful. You know, I mean, I like being a successful technician. It's very frustrating when you're not. It is. Well, anything else?
Yeah, I just I had a question. I'm just about hopefully finishing my Wells Gardner 5515. I have blown horizontal transformer, I believe, the little guy.
A horizontal drive transformer?
Yeah.
Oh, I've only seen that fail once, and it was just a broken connection on it. What that? That's almost impossible to blow.
Well, I've tested it for induction, and I have it reads induction on one end and nothing on the other. I just got resistance, but I thought I would try and rewind it, or maybe throw it in and power it up. Now I'm not quite sure what I got.
What are the ohms on it?
Here I got the meter right here. Hang on.
In the secondary side, the output should show a dead short. It will show a dead short. It's just a few turns of wire because you're only driving the 0.7 volts there to the HOT base. I just can't even believe that's bad. I just can't believe it. I mean, if you tell me it is, I guess.
Well, I don't know. I mean, I assume it is. I've got.
Why? What led you to that?
Well, I'll show you I got resistance on the primary is 56.7 with 1383 millihenries, microhenries. And then if I go to the other side,
there's almost no inductance on the other side because it's just a couple of turns of wire. I've never measured it, but it should be almost nothing.
I've always ohm them out, and it's usually 56 ohms on one side and 0 ohms on the other side.
Correct, Paul.
Yeah, I got 7.33 ohms on, and it's got no inductance reading.
Oh, 7.2. Oh, no, that is bad. That's weird. Well, you know, you might try popping it open and just see if you've got a broken wire somewhere. I don't know how it could be 7 ohms.
Well,
that's weird.
I've measured the gauge of wire, and I've ordered it before I pop it open. I thought I'd do that.
Oh, okay. Yeah, it's too serious. You don't have junk you could pop it off of? You don't have a junk chassis that you could take?
Well, would it be the same coil? Like, would I be delivering different voltages?
I think that almost any, I don't know this for sure, but I would think that almost any monitor of the same era, the horizontal drive transformer would be really the same.
I got plenty of junk 4900s here, which is the same.
Sorry, wait, sorry. Let me interrupt you, Paul. 1 second. Sorry. Some modern monitors, the horizontal drive transformer is driven by plus 24 volts. I'm talking about older monitors that don't have switch mode power supplies. Sorry, Paul.
I was just saying, I got plenty of junk 4900s, which are the same as the 5515s.
Oh, really?
So I could send you one if you need one.
I might take you up on that, Paul. Thank you.
Just PM me if you need one.
Okay. I'm going to try and rewind it anyways. The wire's on its way.
Okay.
Yeah, that's crazy. You know, I've done it a few times, but only out of desperation.
That's me.
Yeah. Okay. Why are you desperate? You shouldn't be desperate. Oh goodness.
I'm just kidding. It's I don't know. When I latch onto something, I don't usually let go. I just want to see if it works. If not, I'll gladly contact Paul.
It's good experience because as we get further into this hobby, I find more and more components become unobtainium. So learning to repair them as we go along sometimes is a good skill to have.
Well, Austin, you've been pretty quiet this whole time. Not to shake you out of your reverie there. Do you have any questions? Anything you want us to cover? Or are you frozen? Oh, you're frozen.
No.
Oh, there you are.
Hear me? Okay.
Or Anthony?
Yeah. I just wanted to ask a question. So, I've almost sort of like started picking up this hobby in the last sort of 18 months or so. So when I started, it was pretty green, and like I've got a bunch of arcades that I've sort of started collecting and all that sort of stuff, and acquired a 29-inch Pentranic screen,
Yeah.
the CH288 chassis. Yeah, I think I've bought it a couple of times. It's basically like I haven't touched it since those early days. It's got a vertical collapse on it,
Okay.
and yeah, I was you know, a little bit unfamiliar with fake ICs and all that sort of stuff, and dove straight into AliExpress and got replacement ICs and all that sort of stuff. I changed a bunch of stuff on it. Recapped them on that. I replaced the vertical IC, replaced the HA11235 IC as well. And
That's rarely bad.
yeah, I figured, but it's I'm sort of I'm looking at revisiting this this chassis again, and I've kind of sort of run out of ideas what it could possibly be. The only odd thing that I've sort of found is that the 12-volt feed that drives that HA11235, before it hits it, it's clearly 12 volts, but the moment it hits that IC, it immediately just drops down to about 7.5 volts.
And yet you've replaced that particular integrated circuit.
Yeah, I've replaced it. Yeah.
Wow. You know what would be the best thing then in this case, because I'm really unprepared to answer your question specifically. Could you drop me an email or DM or something like that with just the model number and all that, and then let's work out a time where we can either Zoom together or Skype or something, and armed with a schematic diagram and with you in front of the monitor with a meter in your hand and the ability to fire it up and test some things. Maybe I can talk you through it. It'd be better.
Yep. Great. Sounds good.
That's okay. Anything else?
I've got another weird one.
Okay.
Actually.
Hey, it's why we're here, brother.
Yeah. So I've got a couple of broadcast monitors. I'll move the webcam around a bit.
Like PVMs?
So yeah, they're a Samsung PVM basically. Okay. Yeah, so the top one's a 10-inch and the bottom one's a 14-inch, and so I RGB modded the 14-inch CRT to take in a clean RGB feed.
Does it have a SCART connector on it now? Is that what it was?
It does now, yeah. So now it's got a SCART connector, okay. But the jungle IC that's used on that chassis does natively support RGB. So, but it was basically the circuit was non-existent for the input. Okay. So basically rebuilt that circuit and it works fine. However, I started getting this weird issue where the colors are sort of a little bit oversaturated, very dark. I've got to have the contrast way up and all that for it to sort of get a clean image out of it. And any text that displays is like kind of broken, and it's kind of weird to describe. But
yeah, no, I'm not specifically familiar with what you're talking about, but in this modification, if I mention DC restoration, do you know what I'm talking?
Yep.
You know what I mean? Is that encompassed in the circuit that you made?
No. No. So all I'm basically doing is basically connecting the RGB inputs on the jungle IC to some resistors, out to some connectors.
You mean to pad the signal down from 4 or 5 volts down to 0.7 or something? Or?
Yeah, correct.
Okay.
And then also using a switch with a 5-volt feed into the in order to basically switch it to that mode. But the thing is, this display issue though doesn't have anything to do with the modification itself. Even if I bypass the modification and I go straight composite in, I've got the exact same issue.
Oh. Do you think it's the CRT? I mean, does it happen after how many minutes does it start to happen?
Immediately, as soon as I turn it on.
Oh.
Yeah.
Ooh.
Yeah.
You've got tough ones that I don't.
Yeah,
Sorry.
that's all right.
Pay no attention.
I might sort of post a few pictures up on the group, and that might sort of make it a little bit,
There's a lot of smart
Spanish,
people in
a
this
lot
group. So
more, yeah.
I mean, everyone here, as far as I know, it's pretty interesting. So I'm not sure how much I had to offer today. Anyway.
Yeah.
All right. Well, you want to call it quits for the day? Everybody okay? Anybody else got something to say?
Can I ask a question?
Yeah. Yes,
Sean?
yes. Who's that, John?
Sean, yeah. You mentioned earlier about the herringbone interference, what it looked like. And that also reminded me, I know it's a big topic, but there are lots of issues like monitor troubles that we have that we don't know the right name for it. Like it could be the jitters, or it could be hula, or it could be, whatever. And so I just wondered if you could quickly go through maybe what the types of failure or the issues are, the visual effects that you can see. And what
I don't know about that, but so much. I'll discuss herringbone certainly, but you guys do have a weird way of discussing things. For example, the bottle cap transistors in an XY monitor. I mean, seriously, the transistors that are in the TO3 package that people are referring to as bottle caps or frame transistors, or I don't know, like one person makes something up and everybody just goes, oh, all right, well, that's what it's called. And that's it. All right. So something called herringbone. So I learned all about herringbone interference in my early days with amateur radio, if you care. I was a ham radio operator, but because I didn't get Morse code very well, the fastest I could do Morse code was 5 words per minute. And you needed like 16 words per minute to get a general license and 20 words per minute to be an amateur extra or something like that. They've since dropped the code requirement, Morse code requirement. But I was up in the upper bands as a technician class, one of which was something called 6 meters, 6 meter band. The 6 meter amateur radio band is actually channel 1. Did you ever wonder why on your regular television, the old fashioned TV, it started at channel 2? What the heck happened to channel 1? Channel 1 was the frequency from 50 megahertz to 54 megahertz that they gave over to amateur radio for this, what's called the 6 meter band. Well, that's all well and good, except that if you transmitted on the 6 meter band, which I did, and I used to play like chess over the radio with my high school buddies, the what was called TVI, the television interference, was horrendous. And this is the days before cable TV. Everybody just had antennas. When I was on the air, nobody in my neighborhood could watch TV at all. It was like insane. So what herringbone interference is this? If you think about, I can't even draw a fish here. If you think about what a fish skeleton looks like, there's the fins. The fish skeleton looks like that, doesn't it? I mean, when you look at the fish skeleton. So what herringbone interference is these diagonal lines, and they're very closely spaced typically because they're high frequency, and they are not synchronized with the monitor in any way. Because they're not synchronized, they drift all around. You'll see these diagonal lines just drifting all around. I am not talking about vertical retrace lines. I am not talking about the lines that you see sometimes on monitors that go in this direction, from lower left to upper right. Those are called vertical retrace lines. I'm talking about what I just drew, this kind of stuff. So this is real high frequency.
Are those lines normally on a 45?
Yeah, they are normally at that angle, and they kind of drift all around. They could be kind of move all around. Really, it depends on the frequency of what's coming out of whatever it is. But when you see these things, you are looking at a very high frequency sort of a thing, meaning that it's probably coming from your switched mode power supply in this particular context, in the context of a video game. There's an article, I'll post it, called The Time Machine. I might have posted it up there already. Did I post an article called The Time Machine? Maybe not. Okay.
I don't believe I've seen it.
Okay. Here's the deal. Well, here's an answer to your question. It was about some of the symptoms. Okay. So let's look at a couple of the symptoms. Sorry. Now, remember the way the monitor works. It starts at the left-hand side, starts drawing the line at the left-hand side and draws the line from left to right, correct? When the line gets to the far right-hand edge, it is turned off. The magnetic field resets, and when it's turned back, the beam is turned back on, it's at the left-hand side. So remember that it only draws the line from left to right. Everybody with me? That's pretty simple. I think we all know that. So let's think about this for 1 second. One of the common problems that you'll see is that the screen is normal on the left-hand side, but dark on the right-hand side. And as it moves from left to right, it gets darker and darker, sort of I can't really draw it on the board. It's either bright on the left and normal on the right, or normal on the left and dark on the right. You get what I'm saying. As the image moves from left to right, it gets darker and darker. So that on the right-hand side here, you have this dark area. Well, this has to be caused, first of all, let me back up for a second. Number one, this is synchronized. Whatever this problem is, it is synchronized because it occurs at the same time. Remember, it's time in the horizontal direction here. It's occurring at the same time on every single line. It is producing this dark area right here. So this has to be a flyback derived power supply. It has to be a power supply that comes off the flyback transformer. It has to be, there's a diode that turns it into DC, and a capacitor, which is your failure, that filters it out, because this is happening at every single line. In other words, the pulses that are coming out of this thing happen every single line at the exact same time. And remember that this is important. The lower the voltage is at the cathodes of the CRT, the more they emit. The lower the voltage is on the neck board for the transistors, the more they emit. That's how they work. So since this capacitor is bad, when the pulse happens, we get a nice pulse through the diode and it charges up the capacitor. But the capacitor then discharges in between pulses. So between this pulse, it's supposed to stay up like this. But because the capacitor is bad, it's discharging. It's not holding the charge the way it should between pulses. And as this voltage drops, sorry, dark on the left, bright on the right. Sorry. As this voltage drops, it causes it to get brighter on one side and darker on the other. So when you see that, it has to be that. It just has to be a flyback derived power supply. There's nothing else that it can possibly be. Does that make sense to everybody? Kind of, sort of?
Yes.
No? Okay. So another thing, though, is jail bars. You might see something where you have these jail bars, and typically it's on the left-hand side where you see these jail bars, and they kind of fade out like this. Has anybody ever seen that? Jail bars on the screen?
Yes.
Okay.
Yes.
Okay. So in this case, it's also caused by a bad capacitor, but in this case, it's something known as ringing. It's flyback ringing. That is to say, as the pulse drops like this, it is causing what we call a ringing effect like this. And each one of these ringing thingies is one of these dark bands like that. Well, that's caused by, I'm sure you're familiar with the C57 issue with capacitor C57 that fails, or I forget which it is in the other monitor.
511.
511, thank you very much. C511 or C57. And what that capacitor is it's on the B plus power supply. So we have the B plus power supply, it's like this, but it is physically close to the horizontal output transistor, typical 47 microfarads, you know, at 160 or something like that. Could be 100 microfarads or whatever it is. So it is in parallel with the main AC, the main filter capacitor. So you'd think, well, it's just in parallel with it. Why would they need it? The reason you need it here is that this is right where it goes into the flyback transformer. And it is to prevent this ringing. It is to prevent the ringing. It presents what's known as a low impedance, which we abbreviate with a Z, a low impedance source right next to the load, which is the flyback transformer. We really want the power source to be as low a resistance, as low an impedance as we possibly can. And when that capacitor fails, it allows that ringing into the power supply. It just rides on top of the B+. It's just a ringing that rides on top of the B+ that causes the jail bars. So that's that. Now, in some cases, you might see weird jail bar stuff that comes from the switch mode power supply. It's something to be aware of, that in the switch mode power supply, sometimes in some of these power supplies, they will synchronize to the horizontal. They'll take a little bit of an output from the flyback transformer somewhere, typically run it through a resistor or something like that, and it goes in to synchronize the power supply with the horizontal frequency. So if you have a power supply failure and they are synchronized, whatever you see on the screen will be synchronized. It won't be moving around, in other words. If this is not synchronized, in other words, if it's not, that's not the design, that's when you get the herringbones that kind of drift all around because they're not synchronized. But if they are synchronized, whatever you see will stay solid like that. Make sense, right? You know, the best thing, I'll upload this article. I wrote this article called The Time Machine. And once you understand how the monitor works, you are just looking at a timing graph here. Like in standard resolution, it's like 50 microseconds for the beam to move from left to right. And it's 14 milliseconds for the beam to move from the top of the screen down to the bottom of the screen, 14 point something or other. And once you understand how those timing things work, I'll post the article. It makes it much easier to look at the monitor and see what the symptom is and try to figure out what, you know, what circuit is that's the problem, if that makes sense. And you know what, guys? I think I've had it for now. Anybody else have any other questions for now? I need to call it quits. Everybody okay? Any other questions about anything, life, the universe, and everything? Well, I'm going to do it again next week. By the way, I'm back. You know, our government's sort of back in business. I got a vaccination shot. I'm a little more upbeat now, and I'm not as frightened to go do stuff. So,
good news. Good news.
Yeah. Anybody else? Mike, any questions? Joe, anything else? Sean, anything else?
That's super helpful. Thank you for doing it.
Anybody? Okay.
Yeah,
Oh, there's your doggy. There he is, Eric. Yeah. Hi, buddy. Hey, nice to see everybody. Same time next week. And again, I'll post this recording on the website, and I'll post the article and stuff like that. Just give you a little bit.
Thanks, Randy. Great.
All right.
Appreciate it.
Take care, everybody. Talk to you later. See you next week.